Most people think in words. They narrate ideas to themselves, sentence by sentence. Temple Grandin does not. Her thoughts arrive as images, complete, detailed, and immediate. When she hears a word like door, she doesn't process a definition. She sees every door she has ever encountered, layered at once. This wasn't a technique she learned. It was how her mind worked from the beginning. That difference would later make her a scientist, an engineer, and one of the most influential figures in modern animal science, not despite thinking differently, but because of it. This is a case study in how cognition shapes capability. Temple Grandin describes her thinking as entirely visual. There is no internal narration running alongside the images. Concepts appear as concrete examples, not abstractions. This form of cognition changes how problems are detected. Where most people rely on language to summarize a situation, visual thinking preserves detail. Small irregularities stand out. Patterns appear spatial, not verbal. In environments built around movement and pressure, this matters. Animals respond to shadows, reflections, angles, and sound echoes. These are details easily ignored by people thinking in words. Grandin noticed them immediately. A dangling chain, a sharp contrast on the floor, a reflection that looked like a solid barrier. To her, these were not theories. They were obvious features of the environment, and once seen they could not be unseen. This allowed practical changes to be designed with precision, reducing confusion, stress, and failure without relying on interpretation or assumption. When Temple Grandin began working with livestock facilities, she noticed something others consistently missed. The animals were not resisting the systems, they were reacting to them. Chutes designed on paper looked efficient to human planners, but from ground level they created confusion. Harsh lighting caused glare. Sudden contrasts appeared like drop-offs, narrow angles felt like dead ends. Grandin walked through these spaces the way the animals did. She followed their line of sight. She observed where movement slowed or stopped. A shadow across the floor could halt forward motion. A reflection in metal looked like a barrier. A dangling object created unpredictable motion. None of these issues required force to fix, they required adjustment. By removing visual stressors and smoothing movement paths, animal flow improved. Injury rates dropped. Handling became calmer. Efficiency increased. These changes were measurable. Facilities redesigned using her principles reported reduced stress responses and fewer errors during processing. What made this possible was not intuition or empathy alone, it was perception. She translated visual information into functional design. She turned cognitive difference into structural advantage. The systems didn't become more complex, they became more aligned with how living organisms actually move through space. Temple Grandin's work illustrates a broader principle. Systems are shaped by the minds that design them. When all designers think the same way, the same problems remain invisible. Visual thinking did not give her more intelligence. It gave her access to different information. What others filtered out as noise, she registered as signal. That difference allowed improvement without adding complexity, force, or control. Progress came not from changing the subject, but from changing the frame. Temple Grandin's impact came from seeing what others overlooked.